We make a lot of decisions every day, right? There's what we're gonna eat for breakfast, then our post-breakfast snack, then of course the most important decision, lunch. I'm feeling pretty hungry right now, can you tell? But how many of us use math to inform all these decisions we have to make? Just me? For instance, a part-time introvert may need to consider how likely it is they'll have to deal with a crowd before going to any store in the mall. Like some stores might be packed because of a sale, or there are stores that are more popular during certain seasons, like ice cream places in the summer. So which one should they go to? Or could they brave both? And if trusting our gut feeling isn't enough, figuring out the probabilities of people being at their favorite store might be a well-calculated route to take. We can even weigh different options and see what happens when we choose one or the other, or both. Decision-making can be exhausting, but with probability and a Venn diagram, we can accomplish anything. Well, not anything. I'm Jason Guglielmo, and this is Study Hall Real World College Math. Last episode, we started talking about probability, which is a way of describing the chance something will happen with a number between 0% and 100%. Or 0 and 1. If something has a probability of 0, that means it's impossible, and 1 or 100% means it's guaranteed. In this episode, we're going to start establishing rules that will help us find the probability of something happening when we combine events. Specifically, we'll learn how to calculate a probability when one event or another might happen, and how we can use a table or a Venn diagram to figure it out. For people like Ebony, this could be helpful to make life-altering decisions, like figuring out which store to shop at to avoid certain crowds. While scrolling on Twitter, Ebony stumbled upon a report about the most visited stores at her local mall. On that list, she saw her favorite shoe store that usually has the coolest sneakers, and that ice cream store everyone's been talking about with the best cookie dough ice cream. Now, Ebony is willing to drop a fair amount of money at either store, but she's less willing to deal with a crowd. So before she heads to the mall, she wants to know how likely it is that either store is too busy and crowded for her liking. And this is where things get probable. Ebony needs to know the probability other folks want to go to the same stores she does. So relying on that trusted, well-respected, and reliable report from Twitter, Ebony is gonna figure out this math thing in the name of protecting her social anxiety. The report included a table with a week's worth of survey data from 1,000 people who went to the mall, and whether they visited the ice cream store, the shoe store, or neither. Not sure why the report conveniently only showed the data Ebony needed, but that's neither here nor there. The table tells her how many people did or didn't go to each store, but it doesn't tell her how likely it is that people will be at both or neither store. So let's throw these numbers into a Venn diagram instead and think about it. We have one circle representing the shoe store and the other circle representing the ice cream store. Altogether, Ebony figures that 700 people went to the shoe store at some point out of the 1,000 folks sampled at the mall, by adding the 220 people who only went to the shoe store and the 480 people who looked at shoes and went to get ice cream. Then, to calculate the probability someone from our sample went to the shoe store, we think of this as an empirical probability, because it's based on observations, and divide the number of people that went shoe shopping by the total number of observations. In math, we'd write that as the probability someone visits the shoe store equals 700 divided by 1,000, which equals 0.7. which can be converted to 70%. Assuming the 1,000 people surveyed are a good representation of everyone visiting the mall, that means we think there's a 70% chance a random person visiting the mall is gonna go to the shoe store. So for Ebony, the shoe store is probably a no-go. We could look at this another way by figuring out the probability someone didn't go to the shoe store. 160 people went to get ice cream, and then 140 people were just elsewhere roaming the mall. So the probability of people not going to the shoe store is 300 divided by 1,000. Or a 30% chance. In math terms, the set of people who just went to the ice cream store or said they went to neither store is the complement of the set of people who went to the shoe store. We talked about complements in our set operations episode, and it makes sense that 70% and 30% add to 100%, because a set and its complement should make up the entire universal set, or everything we're interested in. Ebony knows to avoid the sneaker store, but really she wants to know how likely someone is to go to the sneaker store or the ice cream place. To really get the picture and accurate details, we need to consider our Venn diagram a bit more closely. We already know the probability of people going to the shoe store is 70%, and by the same method we just used, the probability of people going to the ice cream store is 64%. But to calculate both of those probabilities, we had to consider the people who went to both stores. So, to find the probability someone went to either store, we can't quite just add up the probabilities because we'd be factoring in the people who went to both stores twice. Our Venn diagram is useful for visualizing here. To calculate the probability of people going to the shoe store, we added everything in the first circle. Then to calculate the probability of people going to the ice cream store, we added everything in the second circle. So we counted the part where the circles overlap twice. Fortunately, at some point in our rich mathematical history, mathematicians figured out how to clear this double counting up. We just figure out how to count the overlapping part once. Sweet. So the probability of going to the shoe store or going to the ice cream shop is the probability of going to the shoe store plus the probability of going to the ice cream store minus the probability of going to both spots. Actually, what we've done here is recreate a formula that we can use anytime we want to find the probability of one event or another happening. We call this the addition rule for probability. If we label our shoe circle S and our ice cream circle I, then we can write the addition rule using set notation. You can see we subtract out the middle overlapping area of the Venn diagram, so we only consider the part where the sets overlap once. Working through that formula, we find that there's an 86% probability that Ebony will have to run into somebody at either store no matter what. Them's the breaks. Making a Venn diagram is really helpful when we're trying to visualize complicated sets. But we could have also done these calculations using the original table from the report. If we divide everything in the table by the number of people who were surveyed, the 1,000, then we would get a table of decimals that we can read as probability percentages. So we can easily see the probability of each of these events happening. And now that we can see all of this clearly, we know one thing is for sure. It's very probable that Ebony is just going to buy some shoes online and order ice cream delivery. Ultimately, the rules for calculating the probabilities of multiple events can help us make informed decisions, like how the addition rule can help us calculate the probability of one event or another happening. And since nothing happens in a silo, most of the time we need to know how multiple events impact each other all at once. In our next episode, we'll go into more detail about when and how to calculate the probability of events that may or may not impact each other. Thanks for watching Study Hall Real World College Math, which is produced by Arizona State University and the Crash Course team at Complexly. If you like this video, give us a like and subscribe. You can learn more about ASU and the videos produced by Crash Course in the links in the description. See you next time.